Thank you very much for inviting us to share some of our thoughts of how we understand science. I'm the director of the National Institute of Chemistry. My name is Gregor Anderluh. We are working here in Ljubljana on various topics at our research institute. How we understand science, it's a very important question, especially nowadays in this COVID epidemics times where science came into the spotlight really with all of its advantages, shortcomings, and how we understand science, how scientists understand science, how wider public understands science, how citizens understand science. This may be different things, and I will try to share some thoughts in my presentation on that. I will also share some of our recent activities here at the National Institute of Chemistry. National Institute of Chemistry is a research institution in Slovenia. We are a public research institute, and we are active for 75 years. So it began after the Second World War with humble beginnings. There was only one person at the beginning, and the aim of the institute at that time was to help to rebuild national economy after the Second World War. The main research topic at that time was research on properties of coal. So this was something that industry at that time needed, and therefore the politics at that time established research institution. There were also some other institutes established in that period. So during the years, our institute, of course, grew. In 70s and 80s, there were a lot of research projects with Slovenian chemical industry. In 80s and 90s, we started to collaborate a lot with Slovenian pharmaceutical industry. This extended in 2000s, and Slovenian pharmaceutical industry is now also our main industrial partner. However, we, of course, our primary goal of our activities is to provide excellent research. Our mission is to contribute to expanding knowledge of chemistry and associated disciplines, transferring this knowledge to younger generations and wider into the public, and applying newly acquired knowledge into the industry. So this is something that it's not really special in a way for a research institution such as ours. If you look at other research institutes or universities that are that has research at very intensive level, you will see more or less the similar mission. So our aim is to provide new knowledge and to somehow place it into the wider society in many different forms. So today, science nowadays exhibit a lot of interest, and there's a lot of societal challenges that science can help in addressing, that science can help in working on. Despite being in times where corona epidemics kept us busy for the last couple of years, there are still unmet needs in goals proposed by United Nations. In many cases, national governments, research institutions emphasize their research priority based on these goals. And it is the same in our case. For example, there is more and more need for energy. Electrical mobility is at the forefront. And because of the electrification of the processes, of industrial processes and society in general, we need more sustainable solutions in that area. Efficient energy use, efficient ways on how to store energy are important to address, and we have quite an important program on battery research, for example, at our institute. So degradation of the environment is another really pressing issue, as we can follow these days in Glasgow GOP meeting connected to environment and changes that have happened in the environment. In that sense, again, the development of clean sources of energy is important. Again, the hydrogen economy is one of the important topics of our institute. Hydrogen is one of the future pillars of low carbon society. It's renewable source of energy, and we are trying to seek solutions again, or how to utilize this source as efficient as possible. On the other hand, we have a lot of pressing issues with health related societal challenges. Just to mention, cancer is becoming more and more important disease. It is estimated that until 2035, only in EU, the number of cancer patients will increase for almost 1/4, meaning that cancer may become the most important cause of death in EU. Therefore, a lot of efforts have already been invested in understanding this disease, but of course, the emphasis is still on, and also at least some of our activities are connected to it. And another very vast area connected to aging society are neurodegenerative diseases, which become more and more pressing problem in the European area. So the institute is involved in many different, in many other different societal challenges. We are grateful to funds that we receive for our research work, either through national resources, through Slovenian Research Agency, or through European Union funds, which we try to employ as much as possible. So it is important for societies to have in place means on how to enable scientists efficient research work, and how to transfer this knowledge then back to the society in one way or another. At the European level, the framework program is a fantastic program. I should emphasize that it is one of the pillars of what Europe is actually. I strongly believe in a framework program for research and innovations. It allows conducting high priority research. It allows to conducting excellent research at the European level, and this makes the European Union a competitive a competitive region at the global level. We are happy to see, or I'm happy to see as a director of our institute, that we can utilize quite a lot of different resources from quite a lot of different schemes offered by European Framework Program. And I would strongly pledge that it is definitely taken seriously at the same level by the politicians, or even increased in size in future, because excellent science and translation to innovations, to products, is something that is needed actually if Europe wants to keep or maintain the scientific and technological sovereignty. So research that is coming from our laboratories, from our research institutions, from other research institutions in Europe and widely, is quite complex. The results are sometimes very difficult to understand in a wider context. So the understanding scientific achievements is something that is very important, not only for a particular scientific community that works on a given problem. I'm showing here, for example, brain research related to diseases, or applied research that led to many breakthroughs in genetically modified organisms. And all of these topics are important for society, but they may be controversial as well. And this is something that scientists need to consider when we try to put scientific achievements into the wider public, and also at the level of the society. We need to base our decisions on science and scientific achievements. For example, in Corona times, the trust in scientific achievements, ironically, was a bit shattered in some areas. For example, we are not so happy to see that in Slovenia there's a lot of skepticism against, for example, against basic measures, even such as wearing masks, or if, let's say, more advanced, such as vaccinations. This is the only way on how to get out from current pandemics. And it seems that, at least in our case, we didn't do as a society a good homework with regards to persuading public that these measures are based on scientific discoveries, are based on decades of experimentation, are based on decades of good practices, and that we should trust them in these critical times. Now is more than ever a time to ask ourselves as scientists how we communicate our scientific achievements to the wider society. Communicating results of the research work may not be enough just through common channels, such as scientific journals or scientific conferences. Indeed, we must take into an account that we are also promoters of our research work, that we are promoters of our achievements, of our discoveries, and that and indeed you can see that more and more research institutions, you can see that more and more scientists are using channels that scientists were traditionally in past a little bit reserved or opposed to. For example, notifying a community about scientific discoveries on Twitter or Facebook even during this corona epidemic proved to be very efficient in order to disseminate scientific discoveries into the wider public. We have some very good examples here in Slovenia. For example, Professor Erala, who is also a communicator of science for the last year, the very important prize that is given by Slovenian Scientific Foundation, and this is a very good example on how current scientific achievements are translated to the public as soon as possible in the most efficient way. Scientists, we need also to think constantly on how we do science in the laboratories, how we assess research work, how we publish our results. Integrity of science is becoming more and more important, and it is crucial that science is done on a transparent and appropriate way if we if we expect from wider society to trust scientific achievements and to trust applications of scientific discoveries. So sometimes it is very difficult to think as a scientist, you know, where are we actually heading? You know, you may do everything in a very proper way, but then at the end, the perception of society will be different of what you somehow anticipated. This is the Slovenian road signs that say at the same time up and down. So sometimes it's hard to anticipate the direction where you are heading. So perhaps I highlight here one of the inherent properties of scientific work or scientific discoveries, that indeed our directions are unpredictable. I will highlight this notion by two examples from the laboratory work with which I am familiar with, and I want to highlight with these two examples also the fact that science takes time, and scientists need some time and need some peace to do research, to think about research problems, and then during the years we can build up upon these discoveries to create fantastic things that may be useful and usable for a wider society. The first example is recent breakthroughs in sensing of analytes. This is a topic, a research topic that I worked with for many years. With this example, I want to highlight how much time, resources, and efforts are needed in order to develop a product that can be used on the market for the benefit of the society. For example, this is, I'm showing here a nanopore. Nanopore is a small molecular complex that can insert into the lipid bilayer, and you can, and you can efficiently measure ion currents across such a nanopore. This is something that was being researched from beginning of 90s. This particular nanopore that is shown here on the image, the structure of this pore was determined in 1996. So in the middle of 2000s, the company was established again with 1 or 2 employees. That an aim of this company was to develop sensors based on this nanopores. If something gets trapped into these cavities, then ions cannot pass such a nanopore, and you can detect blockades, and from these blockades you can tell something about the nature of the analyte. So it took almost 10 years to establish a company. It took another 10 years that this company developed a product, put it on the market, and now nowadays we can use these devices. These are handheld devices where you can even sequence DNA through such nanopores. So if you have a nanopore, you can thread, you can pull through a pore a DNA, and based on which nucleotide will be in the pore, the current level will be monitored, and you can directly read the letters of the DNA by this device. This is fantastic. This is a fantastic achievement. This opens possibilities for scientific research in many labs from countries that do not have sufficient resources for very expensive machines, for very expensive apparatuses for DNA sequencing. It opened DNA sequencing research in areas that are not very strong in built infrastructure. So you can go even to the field with this sequencer and sequence DNA. So it took really a lot of time to develop a basic scientific discovery such as nanopore and bring it at the level of using it at the practical level. Another example is research from our own laboratory, research on a plant pathogen Phytophthora. Phytophthora was the causative agent of potato disease, famous Irish famine in 19th century. We have recently discovered that these pathogens use molecules such as presented here on the right hand side to damage plant cells. So this is basically, this slide basically recapitulates several years of research, if I'm not mistaken, 5 or 6 years of research of two bright, excellent PhD students. Vesna Hodnik worked on characterization of particular component in plant membrane that is attacked by these proteins, and Thea Lenarčič was the one who showed where this lipid, when this receptor structure binds to the molecule, binds to this virulence factor of the pathogen. Again, it took us a lot of time. It took us a lot of time because we were not able to separate efficiently these molecules from plant cell. So we have to develop certain procedures during the time. However, once we discovered what was the receptor in plant cells, then the research went relatively fast and relatively smooth. At the moment, we are trying to find compounds that could inhibit activity of these molecules and use them as phytopharmaceutical products. So what we do in science today may be the technology of tomorrow, is the technology of tomorrow. We should keep this in mind. We should keep in mind that science is not something that happens overnight. When we devise strategies, when we devise action plans, we should keep in mind that nothing happens overnight in science. Products are not developed overnight. When we want to use scientific discoveries from the past in order to make something useful out of them, in order to make products out of them. Another very important issue when we speak about the science is that we should strive to support excellent research and excellent science. I'm very happy that we at our institute we are also recipients of European Research Council grants, or I should say our researchers are recipients of European Research Council grants. This is a scheme in Europe that fund an excellent research, fund a research that will, as highlighted with some examples, will become a basis for the products of high technological impact in Europe in the future. It is known through analysis that many of ERC grants directly contribute to the society, either through product development or by guiding policies of building policies of the society. So we should be really extremely proud as Europeans that we have such a scheme, and we should make everything that this scheme would be supported in the future, or even increase funds that are devoted to such a scheme. So at the end, please let me finish these couple of examples that I show about how we understand science. I highlighted some of the pressing issues that we are dealing with science as scientists, and perhaps also as a society. We should keep in mind that science will be inherent to our future, that there will be no future without science, and that we should build this relationship as scientists, as a society, for better understanding of scientific achievements in the future, and for better acceptance of achievements and technologies and products that come from excellent scientific work in the future. With this, I would like to conclude my presentation, and I would like to thank to the organizers of Slovenian Science Festival, of European Science Festival, sorry, for inviting me to present this presentation. Thank you very much.
Thank you very much, Professor Dr. Gregor Anderluh, Director of the National Institute of Chemistry, Ljubljana, Slovenia, for explaining to us how science can provide long-term sustainable solutions for any societal changes, no matter how unpredictable they are. Thank you once again.